What's up, dear math buddies? SHERWIN here. Sir Sherwin, your math teacher, at your service. Welcome to another content where we are learning all about mathematics in an exciting and interesting way. And for today's video, we will learn on how to determine the vertex of a quadratic function given its formula. But first, please don't forget to subscribe on my YouTube channel and hit the notification bell for more updated contents. Welcome back, dear math buddies, to my YouTube channel. And for today's video, we will learn on how to determine the coordinates of our vertex of a quadratic function represented by h and k. But this time, we will try to determine it using a formula. In our previous video, we've learned on how to identify the coordinates of our vertex when we transform the general form of a quadratic function y is equal to ax² plus bx plus c into the vertex form or standard form y is equal to a times the quantity x minus h² plus k. The question is, how will we determine the vertex of our quadratic function without transforming it into vertex form or standard form? The idea of using a formula would be very essential for today's discussion. So join me as we derive the formula in finding for the coordinates of the vertex of a quadratic function h and k. Let's do this. First, let us transform the general form of a quadratic function into vertex form. So we have y is equal to ax² plus bx plus c as the general form of a quadratic function. So first step is we need to group the terms containing x, and that is y is equal to quantity ax² plus bx, then exclude the constant represented by c. Then, we will factor out a. So, we will have y is equal to, factor out a, so we will have x² plus b over a x. Again, copy the constant c. And, after this, we will make this expression inside the parentheses a perfect square trinomial. And that is, we will get half of our coefficient x and square it. So, half of b over a is b over 2a, and squaring it, that is b squared over 4a squared. So, we'll have y is equal to a times the quantity x squared plus b over a x plus b squared all over 4a squared plus c. And remember that the product of our a and third term will be subtracted from our constant. This means the product of our a and third term, which is b squared all over 4a squared, will be subtracted from our constant. Then we will make this expression a square of a binomial. So we will have y is equal to a times the quantity x plus b over 2a squared. Then we'll also combine this one, c minus a times b squared over 4a squared. First thing we need to do is to get the product of these two. Since a is present both in the numerator and in the denominator, then we can cancel it out. So it leads us to c minus b squared all over 4a. Since a squared is a result when we square a by itself. After this, to simplify this expression, we will apply the rules in adding or subtracting fractions, and that is to find for their LCD. So the common multiple between 1 and 4a would be 4a. Thus, it is understood that our c here has a denominator of 1. So 4a divided by 1, that is 4a, times c, we have 4ac. While 4a divided by 4a, that is 1, 1 times negative b squared, that leads us to negative b squared. This means if we are to combine this expression, it can be simplified as 4ac minus b squared all over 4a. 4ac minus b squared. So this is now your vertex form, where h represents negative b over 2a, and your k represents 4ac minus b squared all over 4a. And this formula will help us determine the coordinates of our vertex. For h, that is negative b over 2a. And for k, we have 4ac minus b squared all over 4a. This time, let's apply this in our first example, given y is equal to 2x squared plus 4x minus 6. Since we derived earlier our formula, let's solve our h using this expression, negative b over 2a. And for our k, we will utilize the expression, we have 4ac minus b squared all over 4a. Since our given quadratic function is written as y equals 2x squared plus 4x minus 6, it is understood that our a is equal to 2, our b is 4, and c here is negative 6. So by substitution, we will substitute first our b and our a and solving for our h. So we will have h is equal to negative, b here is 4, and our a is 2. So to simplify, we will have h is equal to negative 4 all over 4. So to simplify, h therefore is equal to negative 1. So our h is negative 1. On the other hand, for our k, so k here is equal to 4, a is 2, c is negative 6, minus our b, which is 4. Please don't forget the exponent 2. And our denominator, which is 4 times 2. Then let us try to simplify. K is equal to, get the product first of 4 times 2, that is 8. 8 times negative 6, it is negative 48. And of course, copy the subtraction sign. Squaring 4, that is 16. 4 times 2, that is 8. Then let us simply combine our numerator. So k is equal to negative 48 minus 16, that is negative 64 all over 8. And our k here is equal to negative 8. So this would be our k. And to determine now the coordinates of our vertex, so we will have the coordinates negative 1, negative 8. And it lies on the third quadrant. This time, let's try to have our second example. Let us determine the coordinates of our vertex of a quadratic function y is equal to negative 3x squared plus 5x plus 1. In this quadratic function, of course, our a here is negative 3. Our b is positive 5. And our c is positive 1. To solve for our h, again, we will utilize the expression negative b over 2a. H here is equal to negative, our b is 5, and of course, our a is negative 3. So to simplify, that is h is equal to negative 5 all over 2 times negative 3, we have negative 6. So h therefore is equal to 5/6. So this would be our h. On the other hand, solving for k, we will utilize the expression 4ac minus b squared all over 4a. Again, substitute the value of our a, b, and c in solving for k. So we'll have 4. A here is negative 3, while c is 1, minus our b, which is 5. Again, please don't forget the exponent 2. All over 4. Again, our a is negative 3. K is equal to 4 times negative 3. We have negative 12 times 1. It's negative 12. Please don't forget the subtraction sign. And 5 squared, that is 25. While 4 times negative 3, it is negative 12. Let us simplify. K is equal to negative 12 minus 25. We have negative 37 all over negative 12. To simplify, K is... So our K here is 37 over 12. So this is in terms of fraction. So to identify the coordinates of our vertex, we will have our H, which is 5/6, and our K, which is 37 all over 12. So the turning point of our quadratic function y is equal to negative 3x squared plus 5x plus 1 will be at quadrant 1 with coordinates 5 over 6 and 37 over 12. Let's have our third example. Let us determine the vertex of our quadratic function y is equal to x squared plus 5x plus 6. So, for us to solve for our h and k, remember to identify first our a, b, and c. In this quadratic function, a is 1, b is 5, and c is 6. For us to solve for our h, so again, we will utilize the expression negative b over 2a. H is equal to negative, our b is 5, while our a is 1. So h therefore is equal to negative 5 over 2. So we can write this one as h is equal to negative 5 halves. So this would be the value of our h. On the other hand, to solve for our k, we will utilize the expression 4ac minus b squared all over 4a. Then, we will substitute our a, b, and c in this given expression, leading to 4 times a, which is 1, c, which is 6, and our b, which is 5. Then, same with our denominator, a here is 1. Let us simplify. K is equal to 4 times 1, that is 4, times 6, we have 24. Then, we will have 5 squared, which is 25, and a denominator, which is 4. So, to simplify, we will have k is equal to negative 1 over 4. Or, we can write this one as negative 1/4. So, this would be the value of our k. So, to write the coordinates of our vertex, we can say that the vertex has a coordinate negative 5 halves and negative 1/4, where the turning point of this quadratic function is at quadrant 3. With this, it is your turn. Please try to identify the coordinates of the vertex of the following quadratic function. Y is equal to 2x squared minus 3x plus 6. Y is equal to x squared plus 4x plus 4. And y is equal to negative x squared minus 2x minus 9. Hope you get the right answer, and if you got it right, please don't forget to like this video, leave a comment, and share this with friends. There you have it. Hope you learned something new today. God bless us all.